Hello, everyone, and thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you all to a very special edition of the NASA Startup Speaker Series, Tech Transfer University, bringing NASA technology into the classroom. In the presentation, you will hear from a distinguished professor and entrepreneur about the value of working with NASA-developed technologies in the classroom and best practices for incorporating NASA IP into your curriculum. Before we get started, I'd like to point out that your microphones will be muted throughout this presentation, so if you have any questions, please type them in the chat box in the lower right-hand corner of your screen, and we will answer them during the Q&A session at the end. Before we hear from our speaker, I'm going to take a few minutes to give you some background on the NASA Technology Transfer and Technology Transfer University programs. NASA researchers are constantly working on the cutting edge of technical development, striving to address the challenges of tomorrow, today. Many of these discoveries have been identified as commercially viable by NASA's Technology Transfer Office. In an effort to realize the full potential of such technologies, the Tech Transfer Office looks for ways to bring these innovations out of the lab and into the hands of companies and entrepreneurs. The Technology Transfer Expansion Program, T2X, augments that mission to include a focus on entrepreneurial innovation and strategic partnerships to help accelerate commercialization. NASA's Technology Transfer University, T2U, takes this one step further by bringing NASA-developed technologies directly to entrepreneurially minded students. T2U helps NASA build relationships with innovative colleges and universities around the country while introducing cutting-edge NASA-developed technology to entrepreneurially minded students. As a quick note, the T2U program is only available to academic institutions in the United States. T2U is an instructor-led program that involves infusing an existing curriculum with NASA-developed technology to enrich the academic experience and potentially launch new startups. In the business-focused execution of this program, students work with the technology throughout the semester to develop and identify potential cases, business plans, and target markets for that technology. Students who want to take their ideas beyond the classroom can utilize Startup NASA, a special program designed to help early-stage startups commercialize NASA technology. NASA offers a non-exclusive startup license to new companies formed with the express intent of commercializing and licensing NASA technology, waiving the initial licensing fees and all other fees for the first 3 years. For more information about NASA technology, sorry, Sean, you can switch to the next slide. For more information about NASA Technology Transfer University, and other initiatives, we invite you to visit our websites or contact us. Also, registration is open for our next Startup NASA Feature Series presentation, which will be given by Link Research on July 21st. As a final note, the flyer on the website is out of date, and you will all receive the revised, accurate version via email following this webinar. I want to thank you all again for joining us today. Our speaker is Dr. Pete McAlinden, the entrepreneur in residence at the Rollins College Krummer Graduate School of Business. Dr. Pete also serves as Krummer's Executive Director of the Center of Advanced Entrepreneurship. Dr. Pete is an Orlando-based inventor and serial entrepreneur who has founded several tech companies and helps others with their ventures through Venvelo, the premier early-stage venture fund in Florida for innovative companies seeking capital and mentoring. Rollins Krummer Graduate School of Business works closely with NASA Technology Transfer at the Kennedy Space Center to create an academic capstone course that enables MBA students to learn how to commercialize NASA technology. With that, I'll hand things over to Dr. Pete.
Great, Michaela, thank you so much for that introduction. Let me bring up my presentation here. Well, I'd like to welcome everyone this afternoon to the presentation on how to commercialize NASA technology. As Michaela said, we've been working with NASA for about the past 9 years, and I'm in a very fortunate position here at Krummer because I'm both the entrepreneur in residence, which gives me classroom exposure, so I'm a full-time professor here at Krummer, and the executive director of our Center for Advanced Entrepreneurship, which is our community-facing organization, and that's how we kind of build the bridge between classroom and community. I have about 25 years being an entrepreneur here in Central Florida. You know, it was actually my doctoral dissertation that led to my first company. And since then, I've built 2 more companies and have helped other folks with their companies, mostly in the tech space. NASA came to Crummer about 9 years ago with a very simple idea. They came with their portfolio of patents and asked us if we would like to find market opportunities for their patented technologies. And this is kind of what I felt like in that moment. For a brief second, I thought I was being punked, or Candid Camera was on me, or something like that. Because we all know about some of the technologies that NASA has created that have made it into the market, but I wanted to show you just a few that you might be aware of, but you may not be aware of. So memory foam, you know, if you have a mattress or a pillow that's memory foam based, you can thank NASA for that technology. And this goes way back into the space program just to keep astronauts comfortable. They also developed a lot of battery-operated tools for the moon launches. You know, if you're up there collecting samples and you need to drill some things or to vacuum up some of the moon dusts and so on, you need tools to do that. So NASA actually partnered with Black & Decker way back when, and that's why we have the Dustbuster we have today. And obviously, it's many, many iterations since then. NASA's also spent a fair amount of time, actually a lot of time on the software side, and a lot on the hardware side of high-resolution GPS. So, you know, obviously when you're sending stuff to space and you're tracking satellites and so on, you kind of have to know where they are. So there's an awful lot of intellectual property around high-resolution global positioning system technology. And one that's kind of near and dear to me, I do a lot of work with special needs and disabilities children. The cochlear implant actually came out of a NASA technology. So this is not an inner ear hearing device. It's actually a brain implant device to help people who are hearing impaired or deaf to hear again. So those are just some of the technologies that I knew about, that I was excited about. So when Crummer was first introduced to the NASA technologies and we started working with the NASA team all those years ago, that's where the excitement really, really began. But it was experimental at the time. You know, it's how do you put a program together? What does it look like from a student perspective? Would any of the students actually be interested? These were all the questions that we really set out to answer in the first time we first engaged with our friends there at NASA. So I actually started with one team, 4 students and 2 advisors. I was one of the advisors as a faculty advisor, and we actually had a gentleman who worked out at NASA who was also a Crummer alum help with this team of 4 students. And we thought 12 weeks would be enough. Let's try to make it into a full course, and that's what we did. And we picked the students. We had about 9 apply the first time through. They submitted a resume, a cover letter, and any LinkedIn information, typically a link that we could find. So we did a little bit of research, and we tried to just put together teams that like a normal entrepreneur would. So the first 2 people you look for being an entrepreneur, or the 2 key members you need to have, are typically a hacker and a hustler. So the hacker is the engineer, the hustler is the salesperson going out and raising the capital, and that's usually the core of the team. And you'll see here, you know, we're looking for some of the technical folks, because obviously this is in part a technical exercise. We're looking for the creative folks to really help brand and market things. Obviously, being a business school, Crummer Graduate School of Business, we want to build something that we can sustain and will grow and benefit a lot of people, everybody who's involved with such an effort. And then finally, the administrator type people, who's going to manage the project, who does all the coordinating of meetings and how do you get a license from NASA, and what does that entail with agreements, who's going to put the finances together, and so on. So thankfully, as we learn more about building teams, one of our faculty members, Dr. Misty Lockery here, one of our management professors, has worked on a project called CATME. CATME.org is its website. This is a really, really good tool for those of you looking to assemble teams and to watch their performance over time. So now we are using the CATME tool to help us assemble teams to be as successful as we can possibly be in assembling teams for any one of these NASA projects. So we ran the program this way for about 5 years. So the first 5 teams, we ran this program one term per year for about the first 5 years. And each time we ran it, the number of students applying grew. The interest in the program grew from a lot of the faculty members, a lot of the outside community. They wanted to know more about the potential of what it is we were doing and so on. And we very quickly realized that probably year 3 or 4, we realized 12 weeks was just not enough time because we were learning a lot of different things. We had to repackage a lot of the things that we were doing. So we knew we needed more time to really execute on taking a NASA technology and parlaying it into a bona fide startup. So we expanded the program. And that's where we came up with this concept of the integrated capstone experience. It's a very unique kind of class here at Crummer because it solidifies everything that the students learned in their first year of our MBA program here into their second year. So this ICE program is actually their full second year. It's 32 weeks. I'll talk more about that in a minute, but 32 weeks of their program, their entire second year. And what we're looking to do is just provide them with a very immersive, interdisciplinary sequence of courses, including substantial experiential components that train students to analyze and launch a new company. So again, they take all of their knowledge, all of their skills, blend them together to develop this new startup. When we built this on, kind of Crummer's mission. So on the framework of forming responsible, innovative global leaders who positively impact their organizations and communities. That's our mission statement. Hands-on is very important. We've got to make sure it integrates all the necessary components of a successful business. It includes all the professors that we can bring into the process, because the professor-student interactions has always been very strong here, and that's a critical part of the success of the team. Focused skill development, so just more market competitive. We want to make sure that any skill development that occurs actually strengthens not just the individual, but the entire team. And because of this experiential piece and everything we were looking to do, it's not your traditional classroom experience. We set aside time every week, but each week was different for each team. So I would consult with a lot of the teams that reach out to some of our friends there at NASA, that work with other folks outside of Crummer, other professors within Crummer, and so on. And this gave them great exposure to what's happening in our broader ecosystem here in Central Florida. So again, we kept it in line with our mission, kept it multidisciplinary, and really broaden their network so they get a really good idea of who and how our ecosystems work to help them develop this startup. So ICE is experiential. There were 4 must things that we had to have in an experiential project here at Crummer. These are the things we decided that we absolutely had to have. Had to be multidisciplinary. It had to involve substantial content from one of more than the classes that we normally teach here, including human resources, operations, marketing, and finance. It has to have impact on your organization and community. And it also has to have a leadership component. And what we liked about the team building, we never appointed a team as advisors. The team had to figure out who was going to lead itself. And usually a natural born leader would emerge and would end up leading the team. Sometimes, they would consult with other professors of leadership here, just to make sure that what they were doing was kind of what was best for the entire team. So a lot of learning in terms of leadership and certainly in innovation. And then the last must-have was ethics and corporate responsibility. That's really big here at Crummer too. So what does corporate responsibility mean? Doing well by doing good. I know that's a very cliche type of statement these days, but is there a project that we can work on that can make a lot of money, that can do well for a lot of folks and bring that back into a community to some benefit? And then one of the nice to haves was a global consideration. Is there something that we can develop that applies to markets from around the world? And that's something else that we focus on quite heavily here at Crummer. All right, and here's what the students really get out of this, what they learn, the key thing. Why do they sign up for a course like this? First, it's NASA. There's just a lot of appeal to get to know somebody at NASA, to go out to Kennedy and just to understand what it is that they do. And they also understand what kind of process the scientists go through, the licensing folks go through. When Michaela and I chat, what does the T2U classroom connection piece of it look like? That's where some of the philosophies and skills come in. But they're all centered on recognizing and seizing opportunities and creating and growing new ventures. So again, think about the memory foam. Think about the cochlear implants. How do we begin to build a business around all these wonderful technologies that are at all these different NASA centers? So the Early Advantage MBA program, again, it's a 2-year program. We developed this course called the Integrated Capstone Experience. It's a total of 32 weeks. We break it into 3 different sections: ICE Prep, ICE Experience, and ICE Cap. And students actually have the opportunity to pick the NASA track through all of those 3 phases of ICE, or they can select a domestic or global consulting project and then go through each one of these ICE steps. So about half of the students here at Crummer sign up for NASA, like that's typically 30, and the other half sign up for domestic consulting or global consulting. So here's what's important about that. No matter what track you're in, the first ICE prep step really includes project management skills, consulting skill, leadership, and corporate social responsibility, some of the things I just mentioned. So usually the first 4 to 6 weeks are centered on those kinds of skills. Let's sharpen them if the team has them, or develop them if the team does not have them. So you'll find, a number of things in project management. A lot of students come in knowing that project management skill quite well. Consulting skills maybe not so much. Our early advantage students are in their early to mid 20s. So they might not have a lot of experience in consulting, and they might not have a lot of experience in leadership. They might not have a lot of experience in corporate social responsibility or the knowledge of it. So we spend 5 or 6 weeks developing those types of skills for them. We're helping them develop them. And then the last 2 weeks, we start to break off into our respective tracks. So the NASA track or the consulting track. And it's these last 2 weeks that I give students an overview of what it means to be an entrepreneur, what it's like to commercialize technology, what MBA students typically value most about this experience. And it's interesting, this is from a source called Illuminate Ventures from this year. Entrepreneurs, especially in the NASA program, they really enjoy meeting entrepreneurs in the classroom and connecting with them outside of the classroom. This includes a lot of our friends from NASA, a lot of our prior companies that we've developed, local entrepreneurs, and so on. They also like mentors, websites, publications, and then you'll see down further is the classroom education program, because this is experiential. They don't want to be lectured to. They just want to experience this themselves. And then certainly the professors. Now, a lot of the professors have some experience as an entrepreneur, and they say that's kind of the optimum mix, a mix of a professor who's been there, done that with a startup before. And then kind of lower on the list are the entrepreneurship clubs. So, and what's in it for the students themselves? These top 3 boxes, I think, are typical of an average class, right? You go in, you take a look at some data, gather some information, create some knowledge, you're tested on it, you either know it or you don't, and then you move on. With this particular NASA effort, we decided early on we wanted to go from knowledge to wisdom to impact. So there was actually an interim step there after knowledge too. So after knowledge, can we glean the insight of what NASA has invented to apply it to a different market? And if we can, how do we develop the wisdom to create the impact of that, not just the technology, but the entire business model, so we have something that's market ready? So what's in it for the students? Taking everything they know from all of their other classes, creating some insight around it, building that into wisdom, and finally the impact. And to do that, I start the students with this principle called Ikigai. It's a Japanese term for purpose. And it's really it's an analysis of 4 things. And this is important for the students to analyze for themselves. So I ask them, welcome to the NASA track. Can you please tell me what you love to do with your life? Is it technical? Is it building business? Is it something in the arts? Talk to me about what you love. How does that intersect with what you do really well? How does that intersect with something that you can get paid to do? And then finally, is it something that the world really needs? Where these four circles intersect, the dead center there is what we call purpose. So that's really what we focus on. Now, when I take a look at what you love with what you do really well, that intersection is called passion. Most of the students think that passion is enough to get you through as an entrepreneur. It is not. There's still levels deeper that we need to go into here. So we have this full discussion of Ikigai and why you really want to do this project from your own personal perspective. And then, of course, where you see mission or passion, mission, profession, and vocation, that's where each one of the two circles intersect. Well, this is where the three circles now intersect. And we take a deeper dive into what people really want out of this project or what they can get out of it. And then finally, determining the purpose. Now, this is a very important discussion, and the students really love this because students don't give this a lot of thought, especially as it applies to a 32-week project, or probably 28 weeks at the time it's presented. But this gives them a real essence of, if I'm going to be developing something, I better have the right kind of purpose behind it. So, excellent exercise to go through with students. I also use Strength Finder in addition to CatMe. Just so students have reference to know that there are things out there, because this is the first time that they're probably exposed to an entrepreneurial process and they know they're in charge of it. So they want to know if it's really something for them. So with the Ikigai, that last slide, and reference books like these, they can really get an understanding if this is something for them. So here, after we talk a little bit about, what they want to do, their purpose, some of the resources that are available, I show them a number of the patents that have actually come from Kennedy. So here's a spreadsheet. They had 100 plus patents when they first came to us, and you see there's a patent number and basically a title. Today it's very different because NASA has a Spinoff App. The references Michaela showed us when she first opened up this afternoon, these are in addition to that, but they're in the same bucket of information. So NASA has done a really, really good job taking their list of technologies and putting them into white papers and things mere mortals can understand. So the NASA Spinoff app will actually give you an idea of all the technologies that NASA has spun off. And when you get into the patent portfolio and start looking at some of these different technologies for the students, they have an excellent index and now database of all these different patents that they have that are available. And I want to focus on materials and coatings because you'll see they have 15 different applications or patents or technologies around materials and coatings. So when I click on that, you'll see that they have smart materials, nanomaterials, insulation materials, and so on. So they do a really good job of giving you an ability and me an ability to drive down into all these different technologies that they've developed. So after the students kind of figure out what they want to do or know more about themselves, what they want to do, we talk a little bit about, what's the difference between starting with a NASA technology and a pure startup. Well, a pure startup, you don't have a license, you don't have a piece of technology that you can license. You have to go search for that. More often than not, you're looking to create something that you yourself will patent. And that will add a lot of time, a lot of effort to everything that you're doing as an entrepreneur or an early stage startup. So, and they're very quick to learn that, it's really a big boost to have a patent repository from NASA that you can reference, leverage, and license to really give your startup a very, very powerful competitive advantage. We'll talk more about that as we go on here this afternoon. So I also tell them, here are the top 20 reasons most startups fail. This is from CB Insights. No market need. So let's not develop something that nobody wants. That's really what that means. And guess why you run out of cash? Well, a lot of startups fail because they run out of cash because they're desperately looking for a market that probably doesn't exist. And your cash just won't last as long as you think it will. Not the right team is the third largest thing why startups fail. So what does that really mean? We better take a look at what that means. And now that we have the CATME tool, we understand the dynamics of a team, we spend quite a bit of time on what the right team looks like and what the right team can actually do to execute a great project like the ones from NASA. So focus is on top three because you see they make up the majority of why the startups fail. Now, that's the first 8 weeks. So the students have been through a lot. They know how to consult, run a project. They have an introduction to the patents. They know a lot more about why they want to do what they want to do through their Ikigai. And now they have a bunch of references, a bunch of books on their bookshelf to reference if they should decide to do so. So the second part of this is what we call the ICE experience. It's 16 weeks long, but it's broken into 2 8-week sessions. So the first sessions, we talk about the tools and the techniques for building a startup. We go over the business model, the minimum viable product, customer feedback, which is critical, what your user's journey looks like, and an introduction to the entrepreneurial operating system. Great book called Traction by Gino Wickman, just so they get an idea that it's not just a random process that we have as entrepreneurs and, success being kind of a serendipity thing or something that happens by accident. So we really want to help the students understand a lot of the tools and techniques to really help them get off the ground quickly, to leverage the opportunity of the NASA intellectual property and so on. Kind of a subsection of that, again, because the students love to have guest speakers come in, especially if they're successful entrepreneurs. I'll bring in folks like a patent attorney. We have a gentleman who comes in every time this class is taught. He's great. He likes working with students. He asks them the hard questions, teaches them how to read a patent, do patent searching the right way, make the most out of what they find for other patents they think are similar to theirs, and so on. And then he and I put together an assignment. Let's have an exercise to find the top 5 most related patents to the one you're looking at from NASA. Because just because NASA has a patent doesn't mean there aren't several, and in many cases, many, many more patents associated with that one, either at NASA or maybe somewhere else. So that's the basis of the first 16 weeks. Tools, techniques, network, and making sure that students understand the technology that they're interested in from NASA, what the market looks like for the other associated patents. So we do that for 8 weeks. And then the second 8 weeks, we actually get into building the business. We have enough data, our network is broad enough, we have mentors that come in. So now it's really time to put together a production, operations, and marketing plan. It's time to figure out how to set this startup up, create a set of financials. If you wanted to go out and raise capital, you actually could. What does your cash flow look like? And so on. And at the end of this session, the students actually present to a group of angel investors that I bring in from the community and to NASA personnel. So this is what some of these 16 weeks look like. Let's just take a little bit deeper dive here. I asked them a question, week 1 of the 16. Said, so with so many patents, why do we not see more commercial products? Why don't we see more memory foams and cochlear implants and GPS type products out there? Maybe they're just hidden. But with so many patents, don't you think we should see more products? So we talk about the different companies and how they would benefit. We talk about maybe what some of their needs would be. Like the big one right now, the students seem to like a lot, is Tesla. Why wouldn't it be great to have some of the NASA GPS technology built into autonomous vehicles? Maybe there's something in the patent repository that we could leverage, and so on. Talk a lot about Apple, because if they're going to build their next car, how's it going to be better than Tesla's? And if we had a NASA technology that could actually perform better than Tesla's, maybe Apple would buy it from us, and so on. But the big company conversation is a good one. The students really like it, and it really, they pick out the companies they like to research, and through our library and the databases that we offer, they're able to come back and really get a great understanding as to where each one of these companies is from a technology perspective, and kind of foresee short term where they might need some additional technology. So we have NASA and its patents, we have these big companies, and then there's this gap, this chasm between the two. And it's not that NASA doesn't promote the technologies, it's just a lot of times these companies don't know what they're looking at. If you just saw a NASA patent brief, you might not know it was used, well, you might know that it was used for a particular NASA use, but how does that really relate to any particular use that you have at your company? So what we do, this is the whole NASA integrated Capstone experience effort. We look to fill that gap because we know it has value on both sides. So let's learn to fill it. So why would companies care? So let's say we researched a company, there's a great NASA technology that they're probably not aware of. And if you see a market need for it within that company's portfolio and critical need, why would companies care? How would you pitch it to them? Well, companies care because we're on this accelerated path of we've got to do much more work more quickly. So the waves of innovation, companies realize that if they're not keeping up with technology, they're going to get steamrolled very, very quickly. So the speed and I'll call it speed and impact of what they're looking to do has to increase. And those waves of innovation, they just get higher and higher and more compact, meaning they occur in less time as time goes on. They also have to push through what we call the Gartner hype cycle. So the students and I have a great discussion on where are the technologies related to, I'm looking at the gray bar here at the bottom. Where is it too early for a real market to pick it up? Do we know that it's going to have a ready-made market? Are we at the peak of inflated expectations where people have overhyped it? And now that they've overhyped it, it's going to come crashing down where people like it was oversold. We just don't see any use for it. That's the trough of disillusionment. And if companies can actually get through that trough, they're well on their way to great things in the marketplace. So that's really a great discussion on the Gartner hype cycle. You'll see this one's dated as July of 2017, so 4 years ago. I wanted to pick one that actually came from a few years ago because you see right at the bottom of trough of disillusionment is augmented reality. And now 4 years later, we know where that is. It's in a lot of Apple products. Pandemic has certainly helped develop a lot of augmented reality stuff and so on. So knowing where a particular technology is on this curve is very, very important. And anything past the trough of disillusionment is really market ready. You actually probably want to pick it up just before where this red arrow begins, if it's promising. But these are the areas where the students, they're picking technologies that are in this part of the curve where that red arrow indicates. And of course, we relate this to all the other well-known business models that are out there. Crossing the Chasm by Jeffrey Moore. The trough of disillusionment is the chasm from his work that precedes the hype cycle by many decades. So it's a great discussion just on what everything you need to do about customer acquisition and what their expectations are. And they also must perform like entrepreneurial organizations. What does that mean? That means we have this opportunity with NASA, and this company is looking for some kind of value from that technology. And if we build the technology the right way with the right people and have the right money behind it to keep everything moving forward from an investment perspective, that's when that opportunity creates the value for any particular company. So the goal at this point is to really make sure that the business model that the students are developing has some value, some merit, some kind of overlap with the company's business model. Because once the business models overlap, it provides a great opportunity for students to approach the companies to say, we've studied your business model. We think we have a technology that would help your business model grow. And here's our business model to make your business model grow. So that's always exciting. And then, of course, we practice what we preach. And this is the hype cycle for being an entrepreneur. You usually start with a piece of R&D. You start with a startup company. You think you need money. You get some pretty good visibility. Some people get excited about it. And next thing you know, you have negative press or that technology is never going to work. You're probably out of money at this point, and so on. So the students really take what they're learning in theory and now in practice in building their startup, and then they begin to equate those two. So our job, obviously, as a team and as what we do in this entire curriculum is take as much risk as possible out of the process of commercializing the NASA technology. And that really means when you're going to a company, what are they looking for? And what are they not looking for? You know, you can go to a company and say, we have a great technology, but the first three questions they'll ask you are, okay, so what does it do to my bottom line? So from a market perspective, is it going to provide a great return on investment for us? And if you say yes, they're going to ask you to prove that. And how are you going to know that? So we better have some data. The technical piece is actually the easiest piece, because you say, well, we've licensed this patent from NASA, or we plan to license this technology from NASA. They know the technical aspects is really good. And then the third part of this is the management side. So how do we integrate this into everything we're doing as a company already? Because that's risky too, to pull people off a particular team, to manage that team, to go after something that we're not currently doing. So what is a company really looking for? What do they want? They want a packaged product. Prototypes are great for just demoing things and so on, but they're like, that's still too risky. If you gave us something in a box that we could bolt onto something we were doing, it would be much preferred. So we start with a lean startup methodology and value proposition design, two excellent books to help students kind of get their head wrapped around what a business model is and what value proposition is, and so on. And this is Dr. Deming. He's a gentleman. I have a background in industrial engineering. I read a lot of his stuff. I like this quote from him: without data, you're just another person with an opinion. So let's go out and make sure we really understand what our market is telling us to build. Let's build that particular product and go back to that market and those people that helped us get to a point where we have a marketable good and sell it back to them. So we start with a lean startup method. You'll see it's just two components: customer development, agile development. We iterate very quickly, which means 3D prototyping things, or just paper napkins and crayons kind of thing. These minimum viable products, just trying to get inside of the head of the customer to develop something that they're willing to pay for or find value in. And these are just like some of our chicken scratch notes that we've developed over the years. Customer development is how you search for your appropriate business model. You understand that cash flow, we're going to have to spend cash, and how are we going to, get up and out of a cash deficit as quickly as possible. Because the entrepreneur, first and foremost, has to go with product market fit. And so they jot down, it's customer discovery, customer validation. If the customers do not want the product, we know that's the number one reason why startups fail. You pivot, you start over again. So you start this search cycle. And then from there, you go to customer creation and building your company, which is execution. That's the profitable side of what you're doing. We also bring in a lot of local talent, mentors, people in our ecosystem that love working with students. They're successful investors. They are successful entrepreneurs in their own right. They're business plan coaches, business model coaches. They run accelerators, all these great things. Don't be afraid to bring those folks in. They absolutely love it. This is what the business model looks like. I threw this in. It's way too wordy and for this kind of presentation, but I wanted you to have it in this presentation so you can see what kind of questions you ask to get at each one of these components of running a successful business or developing a successful startup. Most important thing to start with is right there in the middle of the screen, the value proposition. What value from what kind of NASA technology do we deliver to a customer? Well, if we have a customer that we know is looking for value and a NASA technology to deliver it, we've got something to start with. So we keep iterating. Again, this is this agile development process of understanding a company, its markets, and their critical needs, and filling that with a NASA patented technology. And that's the minimum viable product. A lot of it, the viability is there because NASA's already developed it, but how does it need to be repackaged or redone to continue? They systematically test their business models throughout the 16 weeks of this second part of the integrated Capstone experience. And the whole thing is to, for them to understand that failure is definitely a part of this process. And it's only through that failure that you can iterate into a business model that's actually going to work and will plug into a company to add value to what they have. Talk about investment readiness level. A lot of early stage folks think if they just had enough money, everything would be great. So we actually have this discussion of you can't really approach angel investors until you have a prototype of something that's actually working and a customer base that's actually kind of clamoring for what you've developed. You might get away with some family and friends because they love you, they'll give you money, they'll support you because they love you, kind of thing. But it's too early if you don't have at least for problem solution validation done. Students really like this discussion as well. And then finally, they put together a pitch canvas. This is what your pitch deck needs to look like from your business model through everything that you've learned. Let's learn to pitch a group of investors, because the last day of class, here they go. They're sitting in front of you with the rest of your classmates, and you are pitching your idea. So it's a 20-minute pitch followed by 20 minutes of Q&A, and that concludes the second part of our integrated capstone. The last part is what we call ICE Cap. So all of the students come back from the NASA track and the consulting track. They're back into one classroom, and they begin to share the knowledge of what they've learned in their respective track. They talk about cross-pollinations of projects. How did you work out those financials given this issue? How are you going to take the project to the next level? What did you learn from all of your different presentations, from all the different people that you met, and so on? And then they write a reflections paper. So those are the 32 weeks of our integrated capstone experience with our 2-year MBA students. Through this entire experience, we asked them to build their network through LinkedIn, because they meet so many new people, and all of them could be an important part of their network as they go out into their careers or creating a startup. And then, of course, the team building, the performance and evaluation, the CapMe software that we use now helps them understand how they can improve their performance, how they can build better teams, and so on. So that's the 32 weeks of the integrated capstone experience. Let's see, let me take just a few minutes. I'll walk you through one of our past efforts with NASA, because I think this is where the rubber meets the road. So this was our very first effort with NASA, and it was really exciting because, again, there were a lot of unknowns. We had to figure a lot of things out as we were going through this 12-week course. But the student team did such a great job. They named their company Gentura, Connecting Innovation to Industry. So a team of 4 students, myself and another advisor, that made up the team of 6. We went out to NASA, and there was a gentleman, Dr. Bob, wonderful, wonderful guy, NASA scientist. He can explain something to you at any level it needs to be explained. He's just one of those guys. So he developed a very simple, very low-cost device to measure cracks in space shuttle windows. And when we went out there to meet him, everybody, this is where the astronauts used to stand before they actually got on to the elevator to go out to the shuttle and so on. So just an exciting place to stand, very rich in history and so on. So that's always a picture that we take when we go out. This is Dr. Bob on the far left. We're in his lab looking at some of his technologies. And I see 2 of the other NASA principals, Lou and Jeff, in there. And they helped shepherd us through the entire process. So here are the 6 windows on the shuttle. It's not a question of if, it's a question of when those windows will be struck by micrometeorites. And you absolutely have to replace those windows if there's too many micrometeorite strikes, or there's a big enough one where it's actually got a deep scratch in the windows. Here's what one of the windows looks like in Dr. Bob's lab. So he was showing Jason, one of our Crummer alum now, how his technology worked to detect all these scratches and how deep they were, because you can't see them with the human eye, or they're awfully difficult to detect, and you certainly don't want to miss one, because each one of these windows is about $300,000. So this team came up with their 4P process. They looked for other patents. They sought out different partners. They looked for prospects, which means companies that might have an interest in scratch detection and so on. And they wanted to develop a package where the potential prospect would say, yes, that's something we can do something with. So they reimagined this windshield crack innovation as a 3D printer sensor to print higher resolution parts. And they added very little cost to the machine itself. Now, that's not a big deal today, but 9 years ago, when 3D printers were kind of just coming into the marketplace, they were looking for this kind of sensor for a higher resolution, I call it a smoother printed product. So this is one of the NASA team members here too. And as a hardware engineer, And as a software engineer, he developed this little board that would fit into a 3D printer. They programmed it, they prototyped it, and they demoed how it worked. And quite simply, they said, okay, so if this is what a current whistle looks like printed out of a 3D printer using our technology and our software and the patented licensed technology from NASA, this is now what it can look like. So they packaged it. This is what the initial prototype looked like relative to the packaged product. This is what the team, I call them the men in black because I guess they all decided to dress in black that day, but this was right after their final presentation with the folks from NASA and Dr. Bob there. And it was just a great time. This to me is the picture that kind of epitomizes the program. When you can bring together a Crummer student team and an individual like Jason who really did a great job with Dr. Bob and kind of led the entire team, this is a relationship that I am sure will last forever. And it's just two worlds, one of business, one of high-tech development and so on, coming together. So with that, Michaela, I'd like to thank you for the opportunity to speak with everyone today, and certainly everyone there at NASA, from Dan Lockney up in Washington, D.C., to Jeff, to Lou, to Jim, to all of you. Thank you so much. So with that, I'd be happy to take any questions.